chats. Okay. Let's go live. Let's see. Yes, YouTube is telling me that we're live, so let's do this. Doing part 2 for hashtag advent of code 2022, day 11, part 2. Come hang out. There we go. Let me just drop it in a few places. Yeah, doing part 2 of today now. Let me just copy paste this and put this in my Telegram as well. Boom. And let's also send it to a few places on Discord, like my own server. Doing part 2 now. Yeah, let's not bother too many other places with it, because I think it will be a shorter stream. Because yeah, Monkey in the Middle, we did the first part earlier today. Let me just copy a link to that and let me pop out the chat. Sorry, just getting started and live. Let's copy this link. Okay, should be fine. Part 1 from this morning. There we go. And doing part 2 now. And let's pin that one. Okay. Now that that is out of the way, let's refresh what we did this morning. Basically, it's we need to do day 11 over here. Okay. What we did was this challenge. Let me just quickly go over it again, and then we'll jump into day 2. So there was Monkey in the Middle was the challenge. And basically they were throwing away around your stuff. These are the rules that we have to parse. So every monkey has some items that they start throwing around. They have a rule how the number is multiplied. Then there is a test, and based on the outcome of that, it throws it to one of 2 other monkeys. We coded the solution for that. We created a monkey class that's here like this. That has the amount of items that it handled. So that is to get the solution. In part 1 there was a round reduction, which means that after the rule executed, which is this part, it could either be a multiplication or an addition. After that executed, you would divide by 3 to get a lower value, and for part 2 that is no longer enabled. So let's also do bool do reduction. Okay. And basically that will be a public bool do reduction get private set like that. And we need to do that here. Do reduction is do reduction. And so if do reduction, we do that, else return result. Okay. We can actually just keep return result, and we do result divided by is round reduction. Do it like this. So we have an optional do reduction step now. And this is for part 2. So for part 1 this is true, and for part 2 it will be false. Now we need to set that in our constructor here, and then we do bool do reduction, and we pass that along here. So we do reduction equals to do reduction, and then here with parse input for false is do reduction false, true actually. First part requires the reduction. Okay, so now we refactored the code a bit. We added support for that optional step. So yeah, back to the problem. What it basically did was it throws it around, it makes a number bigger, and for part 1 we made it smaller again by dividing by 3 each time. I had a small bug where the negative statement didn't get assigned properly, so it was always 0, so we got into very big numbers right away, but that was a bug. I already coded it to be longs, but since there's a quadratic increment here, there was one that says, let's see, old times 19, that's no problem, but old times old, that is a problem, because that grows exponentially. So when you see something like this, and then for part 2 we have to do it, I think 10,000 times. Let's see. Yes, 10,000 rounds. So let's also add that to the code. Constant rounds is 10,000. Something that you can do with literals in C# is you can add as many underscores to it without affecting the actual value, and it's great for maintaining readability. So if you define numbers inline and they exceed like 100, they go into the 1,000 range or millions, it's really nice to add underscores there, just so that it, so that it's nicer. Let me make sure, open that here, that works, okay. So yeah, so for part 2 we need to do 10,000 rounds. We had, let me also do it lowercase there, we had 20 in the first one. Let's get the inputs, and we do the reduction as false. And I think we can copy pretty much this whole thing. Let's see. Yes, this one gets changed. Now, earlier this morning I was already saying, like, there's probably a trick that you have to do to make sure that the number doesn't go up too hard. There is something like calculating which number is divisible by all of them, and you can use that to reduce your numbers, and I think that's exactly what we need to do here. So let's try that. I just need to check because I have an extension for it, I think. Yeah. So that's basically this logic. This calculates the smallest number that you can use to divide all the numbers that you feed into it. This only does it for 2 though. Let me see. Get my offset. No. Let me see. So basically what we should do, because I think if I run this now, are your source numbers all prime? Yeah. Let me see. Input 1 divisible, right? It's 7, 19, 5, 11, 17, 13, 2, and 3. So if LCM is just the most, yeah, that's true. I still want to know how the LCM of multiple numbers works, so I'll probably check that after stream, but for now I think I can just multiply them all together and use that. So we can do int LCM is monkeys 0.divisor, and then we do for int I is 1, I smaller than monkey count. Let me put that here. Increment I. I already declared I here, so let's put that here. Shift it around a bit. And then we do LCM times equals monkeys I divisor. And that basically would mean that we do this. Let's see, part 2. So that's still a manageable number. The result is quite big though. Let me see. So yeah, basically that should be the answer. Let me check. That's not right, your answer is too low. Okay, let me see. If you're stuck, make sure you're using the full input data. Okay, that's not good. Let's see. Oh, did I still have the test input? No. Let me see. Let me run the test input first. So there goes my streak of not submitting any wrong inputs. Index was out of range. What happened here? First wrong for you today, just like me, yeah. But this is even weirder because monkeys is only 1 here. Or something weird going on here. Ah, I needed to change the split by. Let me see. Result overflowed here. Oh, wait. How is that possible? How does it overflow there? How is that even possible? Let me see. These numbers are weird. For 10,000 times, it ends up with 500,000. Let me see if at least these values match up. So that is correct. Oh, I didn't get the... Oh yeah, that one is also correct. Okay. So how come it does this? Because it should do this times this. How do I get that result? That is just weird. So, okay, let me see. Oh, because handle count is an int, right? Ah, okay. That's annoying. That is just annoying. So I should have casted those before running that. Okay. It's annoying when it's something stupid like that. So yeah, that is correct. So let's run the real input again. So then it overflowed and then got back into positive again. It's always nice. I wish there was a warning when it just happens. Maybe there is. Let me see. So is this different than what I submitted last time? Probably. Woohoo! Okay, we got it. I was worried there for a second because I was like, how is it possible that it's not correct? Yeah, so there you have it. That was actually the first time that I saw an arithmetic overflow for an integer where it also ended back up to the positive side because it's that big of a number. So that's why I didn't spot it the first time. That's really annoying. There's probably a strict mode where you'll get an error if it does that, but yeah. Okay, learned something again. Because I was like, these, what do you call it? These handle counts, an int range should be fine, but once you do the multiplication here, like if I go back to int here, what I needed to do is actually cast this too long, and then it also spits out the right number. See, now it also does it. So let this be a warning for you. If you do multiplication, even with the smaller numbers, make sure that you cast them too long before the multiplication, or you'll get truncated results. Now I'm annoyed that I submitted the wrong answer because I had a clean streak up till now. Yeah. I think, by the way, for the LCM for multiple numbers, you probably just do it comparative to each other and then just keep the lowest number of every outcome. So you do probably do nested for each loops where you start there, like you do for I is, or for A is 0, and then you do for B is A plus 1, right? And then you do for C is B plus 1, and then you do all the combinations, and then you take all those values and take the smallest one. But as you said, they're prime numbers, so it doesn't matter because just adding them up together is actually the smallest common divisor. Okay, so yeah, that was the part 2. I'm happy that it worked, and I'm frustrated that I didn't catch this stupid bug here. Like cast too long before multiplying, or you'll get limited to int max values. And basically loop around, but yeah. It's good to have a comment. Like if you do something like this, it might be clear to you in the moment, but when you do something like this where somebody else reads it, it's like, okay, why do you do that? It might be good to just add a comment just to explain why. So yeah, I think I'll end it here and go do some other work, and hope to see you again tomorrow morning for day 12, right? So thank you, and see you.